You may be familiar with the idea of the scientific method. In school, we learn that science is defined by its method, and that's what makes it special. In reality, though, it's not quite so simple. The American Academy for the Advancement of Science said that the scientific method, quote, is often misrepresented as a fixed sequence of steps, end of quote, when it's actually a highly variable and creative process. What they mean is that there is no one unified method that all sciences share. Rather, there are varied, related methodologies in different disciplines that are all equally scientific. One way to understand the method of science is by an analogy to recipes, like in cooking. Of course, there are many different kinds of recipes used to make a wide variety of dishes. And each one can be made well or made poorly, and there is even variation when it comes to making the same dish. Different recipes vary in proportions of ingredients, steps, cooking times, and sometimes even basic ingredients. Yet, all of these recipes aim to produce versions of the same thing, and different people will disagree about which recipe is better. Let's look at how we might think about science in a similar way. Thinking in terms of recipes can help us in understanding what goes on in science. The first thing to notice when we talk about recipes for science is we are not saying there is one correct recipe, one correct way to do science. Instead, we want to emphasize the variation among different recipes, and even among different recipes for the same kind of dish. If you are making one kind of dish, say lasagna, there needs to be certain elements. There has to be lasagna noodles layered in a baking dish, with some filling in between, covered with a sauce. With traditional lasagna recipes, fillings might include meat, vegetables, and bechamel, and the sauce is tomato sauce. But there are many variations which might leave out meat, use cheese alternatives, or a different kind of sauce. There are even some lasagna recipes that use sliced zucchini instead of noodles. Though, at that point, it's arguable that what you're making is no longer a lasagna. The point is, there is almost infinite variation in what a lasagna recipe can look like, and experienced cooks sometimes make up their lasagna recipes along the way. The methods of science are the same way. Some elements must be present in order for it to be a particular scientific method, such as running an experiment. But the specific ingredients, how those ingredients come together, and what the final product is like, can vary from recipe to recipe. The three types of ingredients that are present in one way or another in most recipes for science are hypotheses, expectations about what we should be observed, and observations. But what varieties of each of these ingredients are used, how they come together, and what they accomplish can vary tremendously. Scientific research in quantum mechanics, for example, might derive its hypotheses from the rich mathematical theory present in that science, use math to generate the expectations based on that hypothesis, and engineer a complex laboratory experiment to test those expectations. Scientific research in human psychology, meanwhile, might employ an observational study to get an initial sense for relevant factors, then generate a more specific hypothesis, and use theoretical knowledge about human behavior to develop expectations for a future study on that basis. Or here's another example of variation. Some scientific experiments start by carefully specifying expectations on the basis of a clear hypothesis, and then use the observations from the experiment to help decide whether the hypothesis might be correct. Other experiments are exploratory. Scientists use experiments to explore some phenomenon without really knowing what they might find. Exploratory experiments can be used to generate brand new hypotheses about poorly understood phenomena. And when scientists aren't in the business of conducting experiments, but are instead developing scientific models, very different methods are used to compare observations and expectations in order to test hypotheses. The three ingredients of hypotheses, expectations, and observations are involved in one way or another in most scientific research. But what form each takes, how they fit together, and even the order in which they can come together can vary from discipline to discipline, from researcher to researcher, and even from research project to research project. So there is no single unified scientific method that all scientists follow exactly. But that doesn't mean we can't say anything about methods in science. We can say that scientists develop recipes for science.